In this video, I'll show you how to take the note that you've selected and then how to sort of add the complex layers on it depending on how it sounds, what sort of instrument it is. And the one thing I want to say before we get started, nothing that we can do in this realm is going to be complex enough to fully recreate the sound. And what we're just trying to do is get at the heart of it so we can best understand it. So let's go ahead and get started. This note to frequency chart is uploaded to Teams, and you can go and see it for yourself, download it. Basically what you need to do is once you find out what that note is, and even if you have to download a free tuner app and hum the note and have it show you what frequency it is or what note it is, whatever you need to do to track down one of the notes in the part of the song you need, go ahead and do that. And if you're truly stuck, let me know. I can help you individually track down the frequency of your note. Once you find your note, you just go to this chart. So say if the note was E3 here, I would just go E3, and then my frequency is 164.814 hertz. And that's all you're going to need to do. You're going to need that frequency to do any of the rest of the work that we're about to do. Next, you're going to want to go over to onlinetonegenerator.com to get a general sense of the type of sound your instrument makes. Go ahead and type in the frequency of the note you picked out. In my case, I'm going to use 305 hertz. And then get a sense of what type of waveform sounds most like it. Sine is going to sound the smoothest, square and sawtooth will sound more aggressive, and triangle will be somewhere in between. Now to show you what they look like, here's sine, here's sawtooth, there's square, there's triangle. What you're going to do next is go to this additive waveform generator, where we're going to take that frequency that you have and then add in harmonics. And harmonics are multiples of that frequency. So 2 to 3 to 4 to 5 times the frequency. What we're going to do is we're going to use this to create something that resembles a little bit more of the richness of the instrument that we have. So to help you navigate your way around here, first there is a general amplitude mixer, and then all of these things, H1, H2, H3, are harmonics. So H1 is the note that you picked, a fundamental frequency, and then H2 would be twice that frequency, and H3 would be 3 times, all the way up to H11, 11 times that frequency. And then over here on the right where it says sound frequency, that's where you type in your frequency that you want, and below it is the volume that it's going to send to your speakers. I'm going to try to send it fairly quiet for this video, as to not annoy you. Okay, let's hear our frequency is just a pure sine wave. And then we're going to hear and see in the above window what it's going to look like as I add in these other harmonics. So here's a second harmonic, a third harmonic, a fourth harmonic, a fifth, seventh, skip the sixth. What you're going to try to do is actually do your best to try to recreate the sustain or the general character of your note. If your note is a sawtooth, you should follow this precise pattern. Let me show you how this works. First, the first harmonic should just be all the way up. The second harmonic's amplitude should be half. And you'll see that down below when we get to 0.5. So down below here is the amplitude. The third should be a third, which is 0.333, and you won't get exactly that. The fourth should be a fourth, or as a decimal, 0.25, and so on. The fifth is 1/5, the sixth is 1/6, the seventh is 1/7, and when you do this, you'll create a sawtooth wave. If we were to continue this pattern infinitely, it would actually create a smooth sawtooth wave. Well, let's hear how that sounds. Compare it again to this sawtooth wave. Definitely more aggressive here. And that's because this is an approximation. We'd have to add a lot more frequencies to get that full aggressive sound. But it's a great approximation for our uses so that we can use sine as our waveform. All you do to get from a sawtooth to a square wave is actually just take all of those even harmonics, so H2, H4, H6, and you just make them all 0. And there you'll have an approximated square tooth wave. The triangle wave is where it really gets weird. You might not think so because it's the closest in shape to a sine wave, but basically it's similar to a square tooth wave in that you only do the odd harmonics. The difference is that the amplitude is not 1 over which harmonic it is. So if it's a third harmonic, it's not 1 over 3, but the square of that. So it would be 1 over 9 for the third harmonic and 1 over 25 for the fifth harmonic. And also, in addition to that, every other harmonic is opposite, meaning that its wave form gets flipped over. So the third harmonic is a minus, and the fifth harmonic is a plus, and the seventh harmonic is a minus. Yeah, it gets weird. In the next video, we'll take that sound you created and write an equation and graph it. Okay, a couple more things that I wanted to show you here. The first is that if you add these harmonics in a sort of a complicated and unpredictable way, you get waveforms that don't really look predictable or obvious, but much more complex. And that's actually more consistent with the music that we hear. And also, if I play this sound, it pretty well matches up. The other interesting thing is if I invert any of these waveforms, the wave visually changes, but I hear doesn't. The reason why these big changes to the graph don't actually make big changes to my ear is because I'm actually still hearing the same frequency, but instead of the speaker playing that frequency by moving out and then back, it's first starting by moving backwards and then forwards. And so its actual path that the speaker is taking is significantly different, but the frequency that makes it up and that my brain perceives is actually still the same. One more final piece just for fun. When you go to onlinetonegenerator.com and you open up multiple tabs and press play on multiple tabs to try to hear a bunch of audio sounds together, they don't actually sync up like they do in the other additive waveform generator. And so because of this, you can actually offset the phase of the sounds. So what I'm going to do here is I have two tabs open at the same exact frequency, 305 Hertz. I'm going to go ahead and play the first one as a sawtooth wave, and then give multiple examples of what happens when I click play on the second one. Depending on exactly when I hit play and where it kicks in, will create a totally different sound.